Good day po. My name is Rainier Francis E. Espinola from BSSE 3, Bachelor of Science in Electronics Engineering, third year. So this is the sixth episode of our series explaining the different laboratory activities that we have performed in our subject, signals, spectra, and signal processing. So our sixth laboratory activity is entitled Sampling and Aliasing. So by the end of this activity, the student should be able to generate continuous time sinusoidal signal and sample it in a different rates. Then observe aliasing or aliasing when the sampling frequency is below the Nyquist rate. Lastly, to analyze the difference between the properly sampled and aliased or aliased signal. So a little background. Sampling is the process of converting continuous time signal x of t into a discrete time signal or x of n. Yeah. So sampling is done at intervals or of 1 over Fs, where Fs is the sampling frequency. So the Nyquist-Shannon sampling theorem. According to them, a band-limited signal with maximum frequency can be perfectly reconstructed if the sampling frequency is greater than or equal to uh, the double of the max frequency. Ayan. Aliasing naman, if the sample is less than twice the maximum frequency of the signal, higher frequency tends to fall back into lower ones, creating distortion called the aliasing. So let us now proceed with the program. So then we have import some libraries such as the NumPy and Matplotlib. So the NumPy is responsible for array operations and signal generation. The Matplotlib, on the other hand, is for plotting our signals. Now, let us run the code. And first off is we need to generate continuous time signal. So we need to introduce or we need to set a frequency of the signal to 5 Hertz. Then generate continuous time access from 0 to 1 second with 1,000 points or fine resolution. Ayan, fine resolution ang tawag ito. So that is from 0 to 1 seconds. That is the line space. So we need to define the continuous sine wave, that is x of t equals to our sinusoidal signal, that is equal to x of t equal to sine 2 pi frequency times time. So in order to represent that in a code, so we need to represent it by a variable, which is x, sine 2 times multiplied by pi, frequency of the signal, which is 5, then time, then t. So t is the tawag natin, access from 0 to 1 second with 1,000 points. Yeah. Next block is we need to plot the continuous sine wave. So we need to plot the t, the x, then our label to that is the continuous signal. Then we need to provide the title and the label for our axis, that is for x-axis and for y-axis. Then we need to grid it so that we can see the values. And then we have legend in order for us to compare. And then we have a footer, and we can have a signature footer, or we have a signature footer for that. And then type layout, then show the output. So as we have run the, ayan. So yung label or yung legend rather, ito pala. Ibig sabihin nitong blue is a continuous signal. Okay. We can compare naman it and present it into in dalawa. So, pero so next is the sampling process. For sampling process, we need to introduce two type of frequency, which is the high and low. So the higher, the 50 is higher than the uh, since our frequency here for the sine wave is 2, therefore we need a frequency that is higher for 2, that is 50. So no aliasing. So this frequency would result with no aliasing. And this low frequency would result to aliasing. So aliasing will occur to this frequency. So our variable is frequency high and frequency low. For n, we do to set a discrete time samples at 50 hertz. And then we need to sample sines wave. And so for low rate sampled signal, this represent the discrete time samples at 6 hertz. Dun sa 6 hertz natin sa fs low. And ito yung sample wave niya, sine wave, alias na to. Ito naman, sa 50, that is a perfect sampling of our sinusoidal. So let's proceed to the subplotting, with the plotting method. So the figures, we have a font size of 12 and 6 and create a white figure. So, ayan, pwede natin i-compare yung dalawa that has yung dalawang plot natin, which consists of uh, the signal that has no aliasing and the signal that has aliasing. Does aliasing occurs? Okay, kikita natin. So yung first plot natin, which is in the position 1, for plotting stem or discrete, para lumabas siya na discrete siya. And for our title and labels. Then legend. Undersampling naman, that is, ito block of code that is for plotting our something that is above the Nyquist rate. Nyquist rate. And this block of code naman, ginagamit natin para ma-represent yung yung undersampling, which is yung nag-occur yung aliasing natin. So filter for the whole figure. Then adjust the layout to avoid overlapping of the plots and display the plots. So ito na lalabas. So as you can see, yung nasa taas, which is the proper sampling, that is 50 hertz, you can see that the sine wave or yung blue line, which is the sine wave natin, is perfectly represented siya. Kumbaga, makikita mo yung mga red na discrete samples can show the sinusoidal wave. However, dito sa pangalawa, we can see the aliasing because lower or undersampling siya. So pag inalis natin to blue, makikita natin is yung green lang, hindi natin siya makikita as a sinusoidal wave. So there is a distortion. This type of sampling could result to a distortion and aliasing. So that's what we call in this video. Now let us proceed. Expected result. Let us proceed with the guide questions. So what condition must be satisfied to prevent the aliasing according to the Nyquist? So our answer to that is that the sampling rate must be at least twice the highest frequency of the signal para ma-represent natin perfectly yung ating sample or yung original signal natin. So what will happen when the sampling rate is exactly equal to twice the frequency? Ayun nga dun sa formula natin for the Nyquist and Shannon theorem, dapat yung sampling frequency natin is greater than or equal to twice of the f naught. So it would not, the signal can be still reconstructed, but is at the limit and may have caused distortion if not sampled perfectly. Yeah. So explain why the alias signal appears to have a lower frequency than the original. That is because higher frequency fall back into the lower range when the sampling rate is too low. So last, give a real world example. Well, aliasing is a problem. E.g., audio, for example, is audio recording or video. So when aliasing occurs in a digital audio, so distortion of sounds, video, and image, ito, magkikreate siya ng distorted sounds, ng wagong yung effect pag sa video, and image. So that concludes our uh, laboratory activity 6, which is the sampling in and aliasing.